Section 8.4 is on trigonometry. Trigonometry is the study of triangle measurement, and a trigonometric ratio is the ratio of the lengths of two sides of a right triangle. So we're going to be focusing here on right triangles, and when we're talking about a trig ratio, remember, ratio is just a fancy word for a fraction. So we're going to be looking at fractions created by the measures of the lengths of the sides of a right triangle. So there are three trig ratios that we will be using. They're called sine, cosine, and tangent. So the sine of angle A is the ratio of the length of the leg opposite angle A to the length of the hypotenuse. Sine is the leg opposite over the hypotenuse. The cosine of angle A is the ratio of the length of the leg adjacent to angle A and the length of the hypotenuse. And the tangent of angle A is the ratio of the length of the leg opposite angle A to the length of the leg adjacent to angle A. So let's take a look at another little diagram here. So we abbreviate sine, cosine, and tangent as sin, don't say sin though, it's sine, cos, say cosine please, and tan, tangent. So the sine of angle A, so if I'm looking at angle A here, I'm going to circle it in pink. The side that is opposite angle A is little a over here. That's the opposite. The hypotenuse is always the hypotenuse. That's going to be C over here. And adjacent is the side that is adjacent to angle A. Now granted, angle A is formed by both this longer leg right here and by the hypotenuse. But the hypotenuse is always the hypotenuse, so B would have to be the one that's adjacent. So sine is opposite over hypotenuse. So in this case, it would be A, little a, over C. Cosine is adjacent over hypotenuse. So adjacent is B, so that would be B over C. And tangent is opposite over adjacent. So that would be A, which is opposite, over B, which is adjacent. The way that we have to remember this is using the term SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So let's take a look at an example here. It says find the sine of angle A, find the sine of A, cosine of A, and tangent of A, sine of B, cosine of B, and tangent of B. Express each ratio as a fraction and as a decimal rounded to the nearest hundredth. So I think I'll go ahead and circle these in color so it kind of stands out a little bit. So for angle A, the side that's opposite is the 3. The side that's adjacent is the 4. And even though 5 is adjacent also to angle A, that's the hypotenuse because it's opposite the right angle. So to find the sine of angle A, remember sine is opposite over hypotenuse. So that's going to give me 3 over 5. And that's equal to, I don't need to round that, that's equal to exactly 0.6. The cosine of angle A, cosine is adjacent over hypotenuse, so that's going to be 4 over 5. And again, I don't need to round that one either because that's 8/10. And the tangent of angle A is opposite over adjacent, or 3 over 4, which is 0.75. Now, I think I'll erase the pink ones so we don't get confused, because now we have to do the same thing for angle B. So for angle B, in relation to angle B, now opposite is 4. Adjacent is 3. And the hypotenuse actually stays the hypotenuse no matter what. So the sine of angle B is opposite over hypotenuse, which is 4 over 5, which is equal to 8/10. Cosine of angle B is adjacent over hypotenuse, which is 3 over 5, or 6/10. And the tangent of angle B is opposite over adjacent, 4 over 3, which is approximately equal to 1.33. So now let's use SOHCAHTOA to find some of the missing measures. So here we have a right triangle. One leg is 13, one leg is x, and the only other angle I know besides the right angle is 52. So this is the angle I'm going to focus on. This is going to be, so I need to figure out if I'm going to use the sine, cosine, or tangent of 52 to help me find x. So in relation to this 52-degree angle, x is opposite, 13 is adjacent, and remember this is the hypotenuse, and unfortunately I don't know anything about it, but I don't need to find it. So which of our trig functions uses adjacent and opposite? Because I don't know anything about the hypotenuse, I can't do that. The one that uses that is tangent, because recall that tangent is opposite over adjacent. So I'm going to say tangent of 52, and remember you always do sine, cosine, or tangent to the angle, and that's the opposite over the adjacent. So the tangent of this 52-degree angle is x over 13. Multiplying both sides by 13, because I'm trying to isolate the x, put the 13 out front. Don't put it after the 52, because when you put it in your calculator it might get a little confusing. So canceling those, x is equal to 13 times the tangent of 52, which actually is an exact answer, but I need to round this to the nearest hundredth. So grab your calculator and punch in 13 times, and you'll see the little tan button, tan 52, and you should get approximately 16.64. Here's another example. I have a 61-degree angle, and one leg is 24, and my hypotenuse is x. So in relation to the 61-degree angle, 24 is opposite. This down here is actually adjacent, but that's not going to do me any good because I don't have anything there. And what I need to find is the hypotenuse. So which of our trig ratios uses opposite and hypotenuse? That would be sine. So I'm going to do the sine of 61 is equal to the opposite over the hypotenuse. And now let's solve this for x. This is actually going to get a little tricky because x is in the denominator. I can't multiply by 24 because nothing is going to cancel. So I have to multiply both sides by x, and that's going to give me x times the sine of 61 equals 24, because over here my x's will cancel. And now I need to get x all by itself, so I'm going to divide both sides by the sine of 61. Not by 61, but by the sine of 61. So punching that into your calculator, or actually let's go ahead and write it here. 24, x is equal to 24 over the sine of 61. That's exact. Punch that into your calculator, do 24 divided by, and you'll find the sine button right in front of the tangent button, 61. So that tells us that x is approximately equal to 27.44. And here's our third example. So I have a 27-degree angle, and in relation to that angle, x is the adjacent. This one that I don't know anything about is the opposite, and 19 is my hypotenuse. So which trig function uses adjacent and hypotenuse? Remember, I can't use opposite because I don't know or need to know anything about it. Adjacent and hypotenuse is cosine. So I'm going to take the cosine of 27, and that's equal to adjacent over hypotenuse. And now let's solve that for x. Multiply both sides by 19. So x is equal to 19 times the cosine of 27. Plugging that into your calculator, x is approximately equal to 16.93. So in all of the previous examples, we knew the measure of the angle, but sometimes you don't know the measure of the angle. But if you know, or if you can find the sine, cosine, or tangent of the angle, then you can use what we call an inverse trig ratio to find the measure of the angle. So inverse sine is described like this. If the sine of some angle is x, then the inverse sine of x is equal to the measure of angle A. In other words, what this is saying is what angle has a sine of x. Same thing is true for cosine and tangent. Okay? If cosine of A is equal to x, if I know the cosine of angle A, then to find the measure of angle A, I'm going to do the inverse cosine of x. And the same thing for tangent. And you'll find these inverse cosine buttons right above the regular sine, cosine, and tangent buttons. Just hit second and then sine to get inverse sine. So let's do a couple examples here. Find the measure of angle A to the nearest tenth. So I don't know what angle A is, but in relation to angle A, 6 is opposite and 20 is adjacent. So the trig ratio that uses opposite and adjacent is tangent. So I'm going to say the tangent of angle A, because remember, sine, cosine, or tangent are something you do to an angle, but I don't know the angle, so I'm just going to call it A. Because tangent is opposite over adjacent, that's going to be 6 over 20. So what that tells me is that the measure of angle A, now I'm going to use my inverse trig function, the measure of angle A is equal to the inverse tangent of 6 over 20. Remember, what this is saying is what angle has a tangent of 6 over 20. So I'll do the inverse tangent of 6 over 20, and that will give me the measure of angle A. Punch that into your calculator, and that's approximately equal to 16.7 degrees. Okay. Again, I have to find the measure of angle A, and in relation to A, 3 is adjacent. This one over here is opposite. I don't know anything about that. And 15 is the hypotenuse. So I need a trig function that uses adjacent and hypotenuse, and that would be cosine. So the cosine of angle A is equal to the adjacent over the hypotenuse. Okay, so what angle has a cosine of 3 over 15? So the measure of angle A is equal to the inverse cosine of 3 over 15. Punch that into your calculator. Second cosine 3 divided by 15, and that will give you that the measure of angle A is approximately equal to 78.5 degrees. And our last example in this category, we need to find the measure of angle A. In relation to angle A, 5 is opposite, and 9 is my hypotenuse. The trig function that uses opposite and hypotenuse is sine, so I need to do the sine of angle A is equal to 5 over 9, opposite over hypotenuse, or the measure of angle A is the inverse sine of 5 over 9. And when I punch that into my calculator, I get that the measure of angle A is approximately 33.7 degrees. And our last concept here is about solving a triangle. To solve a triangle means to find the missing angle measures and the missing side lengths. So whatever we don't know about the triangle, we have to find. So solve each triangle. We're on the angle measures to the nearest degree and the side lengths to the nearest tenth. Okay, so here I have a right triangle. I know the hypotenuse is 10, so I'm going to label that hypotenuse. And I know angle B is 62 degrees. Well, probably the easiest thing to do is to find the measure of angle A. So the measure of angle A, because all of these angles, remember, have to add up to 180, is going to be 180 minus 90, because I have my 90-degree angle, minus 62, and that's going to give me 28 degrees. So the measure of angle A is 28 degrees. I could put that in there if I'd like. Okay. Now I need to find the lengths of A and B, the two sides here. So I think I'll use my 62-degree angle just because I have it there. So in relation to my 62-degree angle, this one is opposite and this one is adjacent. So this is good. I know my hypotenuse, so I think I'll start with the opposite. So the sine of 62, that would be opposite over hypotenuse, is b over 10. Multiplying both sides by 10, I get that b equals 10 times the sine of 62, or b is approximately equal to 8.8. And now to find a, little a, I'm actually going to use, I think I'm going to use the 28, and this is going to be my opposite now, and I have my hypotenuse there. So again, I'm going to do sine of 28. Remember, I'm looking at the purple now. Sine of 28 is the opposite, which is A, over the hypotenuse, which is 10, where A is equal to, multiplying both sides by 10, 10 times the sine of 28, or A is approximately equal to 4.7. So remember, solving a triangle means finding all of the missing measures, any missing angles or any missing sides. And our last example here, I don't have any angles here. Okay, all I know is the right angle, and I have two sides and I'm missing one side. So I don't know the measure of angle A or the measure of angle B, and I can't do the trig functions on the right angle because opposite is the hypotenuse. It just doesn't work. But I can use the Pythagorean theorem to help me find A. So A squared plus 6 squared equals 9 squared. In the interest of time, I'm just going to cut to the punch here. A is approximately equal to 6.7. So I'll use 6.7 there. Now I can use some of my trig functions here. Let's start by finding the measure of angle A. In relation to angle A, 6.7, let's see, which one did I do here? I'm going to use the two sides that I know. Actually, it's better not to use the 6.7 since that's an approximation, so I'm going to use the 6 and the 9. In relation to angle A, 6 is adjacent, 9 is opposite. Adjacent and opposite is cosine, so the cosine of angle A is going to be 6 over 9. Or the measure of angle A is equal to the inverse cosine of 6 over 9, which is approximately equal to 48. So angle A is approximately 48 degrees. Now in relation to angle B, 6 is the opposite, 9 is the adjacent, so I'm going to use sine. So the sine of B is 6 over 9. Or the measure of angle B is equal to the inverse sine of 6 over 9, which is approximately equal to 42 degrees.